Good evening. Good evening, everyone. Welcome you all to the new webinar series that we have initiated under the program. These webinar series under the National Program of Climate Change and Human Health have been organized with the objective of reaching out to the state and the district program officers of the National Program of Climate Change and Human Health, and exchanging with them the latest available works that have been done by various scientists in India and at times maybe from countries abroad, which relates to the work of climate change and its impact on health, or potential use of the work that has been done in area of climate change, having possibilities of impact on human health. And this exchange of knowledge, of ideas and understandings and interaction who are people of excellence in the subject area of climate change and its related topics will benefit the program officers in understanding how they need to proceed further in this direction. So today, I would like to bring to this webinar one of a very learned scientist from Indian Meteorological Department, Dr. Pulak Guha Thakurta. Welcome you, sir, to the webinar series. And it is my great pleasure to have you here in this opportunity to interact with the state and district program officers. I would like my officers to have a brief introduction about Dr. Pulak Guha Thakurta. He is currently head of the Climate Research Division at Indian Meteorological Department at Pune. He is a very learned professional. He did his master's, then MPhil, and then PhD in applied mathematics at the University of Calcutta. He's been working in Indian Meteorological Department since year 1992 and has gone a long way on working in areas which are related to climate data processing, long-range weather predictions, operational weather forecast, hydrometeorology, drought research, monitoring and prediction, and various other work that relates to climate change, relates to climate and of importance in area of climate change as well. He and his academic expertise has been well acclaimed. He is a research guide to many MPhil and PhD students in various universities and has successfully helped his MSc and PhD students to finish their thesis and come out as successful scientists. He has innumerable publications, both national and international, more than 50 papers in various journals, and one of his work in the Journal of Earth System Science of Springer is considered as one of the top 5 cited research papers, which shows his excellence and command on the subject. He is also on various expert panels on organizations related to meteorology, including World Meteorological Organization. And he's also been awarded a certificate of merit by the Ministry of Earth Sciences very recently in the year 2020 for his contribution in atmospheric sciences. He's been associated with our program as one of the members of the technical expert group. And today we are here with him because of the leadership that he has displayed in bringing out the web version of the Climate Hazards and Vulnerability Atlas of India for the Indian Meteorological Department in the year 2022. And with that, I would like to invite Dr. Pulak Gua Thakurta to please briefly bring us with the various aspects of this work that has been done and the benefits that it has for the potential benefits that would have for our program. And I would request all my program officers to pay close attention, as it is a very big, huge volume of work, and would probably require to understand it. And he will probably also guide us as how we can continue to find this work on internet. And if you have questions, please do paste your questions in the question answer box, or preferably in question answers box and not in the chat box. And then at the end of the session, we'll try to take in a few questions.
Okay, thank you, Dr. Srivastava. Thank you very much. So as you told that we'll discuss. Actually, first I'll briefly discuss about some presentation that around 25 to 30 minutes. After that, I'll directly show that how that wave atlas can be used from the different parameter, so that it will be beneficial for the state or district official, that how to get the information. So first, I'm just sharing my presentation. Thank you. Is it visible, sir? Are everyone is seeing the PPTs?
Yes, sir.
We're not able to hear you, Dr. Pulak. Please.
Presentation, it is visible?
Yes, sir, it is visible.
Yes, sir.
No, it's not audible.
It is audible at our end and visible also.
Jayashree, could you see if his mic is on?
Mic is on. That I have shared that.
Jayashree, can you put his mic on?
Excuse me, sir.
I
We are
don't
able
know.
to hear and we are able to see that presentation.
Arti, but that they have to. I think there is some problem, or
Okay, it's on.
it is okay, sir.
There probably is some problem is with the connection, sir.
So I
can't get your voice.
Voice, but PPT you are seeing?
Yes, is it me only? Okay, it is. I think it's my headphone.
Yes, sir. Should I-
Yes, yes, sir. Carry on, please, sir.
Should
Please, I can. It was my end problem at my end. I'm sorry. about
Okay,
that.
okay. Thank you, sir.
Yes, yeah, yeah. I
So-
should my problem. Sorry.
So as I told initially, around 25-30 minutes, I will discuss briefly. And then around 15 minutes, I will show online that how that websites can be, that web version of Atlas can be used. And last 15 minutes, we can discuss for if any questions are there. So thank you very much for the invitation and beginning a scope for jointly actually, because it is the interdisciplinary and all should act together to have that climate resilience health system. Thank you very much. As I first begin, basically for building that climate resilience health system, it is necessary to have involvement of both climate scientists as well as health experts, because whatever the climate experts that we cannot, whatever present Atlas, Web Atlas we have prepared, some we have used some societal factors, but mostly it is climate vulnerability. So it is the beginning actually. So that because we required both expertise of your, because mapping of vulnerability assessment related to a health system, joint initiative are required. And in vulnerability adaptation and assessment, if you see the WHO operational framework for building climate resilient system, there are 10 components, and out of basically for all are climate related, but out of that 3 are directly related to this, what we are presently we have done that assessment or mapping of vulnerability over the in country. So first is the vulnerability capacity and adaptation assessment. First is the of that objective. First one is the vulnerability and risk mapping, then modeling, scenario development. In the integrated risk model monitoring and early warning system, there also we require that integrated disease surveillance, early warning, and as well as data on climate sensitive environment and other trends data. This climate resilient and sustainable technologies and infrastructure, they are also required to our adaptation of climate infrastructure and technologies and update of technologies, basically future climate risk projection, it parts of climate projection also. Just one minute. Then climate hazards leading to vulnerability are not basically uniform. It is depends on mostly 5 factors. There are different factors are there. Out of that, societal factor, biological factors, demographic factor, geographical factors. And in geographical factor, basically that we have to see the different risk zones on drought-prone areas, flood risk areas, or coastal storm areas, and water stress areas which are related to flood and drought also. So we need to combine the different factors, not only these factors, also other factor bilateral for have a multi-hazard vulnerability assessment. Also, if you see that basically these are the different classification are there, we have to know that classification because their exposure pathways are different for each of the climate hazard. Just like hydrometeorological hazard, basically related to hydrological and meteorological, just like flood, storm, which are directly related to this hazard system. And some are the indirect, basically climate related hazards, that is biological hazards, where we are also doing some vector-borne diseases, then airborne diseases, waterborne diseases. Each of these are indirect related, and their pathways are given. Actually, these are all documented by WHO, and recent 2021 publication we have given the source also. And each of these events are having different type of diseases, climate sensitive diseases, almost similar types. Suppose waterborne diseases are involved in the increased temperature also, as well as flood also, but their characteristics are different. So we have to identify which are the climate hazards and which are the associated diseases and that pathways, exposure, possible exposure pathways also. Now, what is hazard? Basically, hazard or vulnerability. Basically, any climate event which is beyond, that is extreme events, can be described as a hazard. But if that hazard can define as a diminished capacity of an individual, group, or some society, which gives the impact, that is damages or losses, human as well as other losses, that becomes vulnerability. So that vulnerability can arise from the different factors: physical, social, economical, environmental factors. And that examples are poor design, construction of building. This is related to suppose cyclone, earthquake, or extreme wind speed also. Inadequate protection of assets, and lack of public information and awareness. That is also that joint we have to issue that timely, because IMD is issuing the monitoring and issuing the awareness warnings also there. But along with the warning, that is different temporal, spatial scale, we are giving warning for different extreme events. And use of this vulnerability atlas is because this gives the zone which is more vulnerable, risk-prone areas. Same our warning, if is given for suppose some state, Bihar, it is giving or IMD is giving warning in weekly scale or day to 2 day to 5 days, 7 day scale. If we have this vulnerability map, risk map, same warning can be used in a different management way, which districts or areas are more vulnerable based on past data risk areas. That management can be, preparedness can be taken. So this awareness or public information is very much crucial. The limited official recognition, many cases, whatever warning, risk assessment, risk warning are issued, that awareness is not there. Basically, official recognition is not there. So that leads to vulnerability. And it varies basically significantly with the community and over time also, because same time in future it may not be there. This vulnerability also in 4 types are there: physical vulnerability, social vulnerability, economic vulnerability, and environmental vulnerability. Physical means that is geographical proximity to source and origin. Suppose coastal areas are more vulnerable to cyclonic storm. Fault lines, that is fault line means geological fault line, earthquake, some fault lines already defined, that is seismic zone areas. That if we have the idea that are more vulnerable to earthquakes, then unstable hills vulnerable to landslide. But same structure, suppose wooden structure homes are likely to collapse in earthquakes, even extreme likely means it is less vulnerable for earthquake, but vulnerable for extreme wind. So same structure can be vulnerable for one event, but less vulnerable for other event. Then social information are responsible because inability of people, organizations, societies to withstand with these characteristics, that is community, society, human rights, all are in together. And risk is nothing but the probability, because we have the data, past data, suppose 30 years, 50 years data of different type of data, not only climatological data, societal data, damage data, loss data, damage, all type of damage, including health hazards, suppose health disease data if we have. So we can define the risk areas based on hazard, and that same hazard can lead to disaster, may not be. So simply climate data cannot give the risk. So we have to use that multi type of disciplinary data for defining the risk. And risk can be categorized in basically 4 types: risk acceptance, like that means an informed decision to accept the possible consequence and risk. avoidance in informed decision to avoid the involvement, then reduction, we can use the necessary measurement for appropriate techniques to reduce the likelihood of the risk occurrence, and transfer of the risk. Suppose in many cases migration or shifting of the burden risk to another party, or risk transfer, also insurance are involved. So as I told, natural hazards are severe and extreme weather events that although they occur in all parts, but there is variability is there. So some areas are more vulnerable, some areas are not. And for some hazards it is vulnerable, some hazards it is not there. And as the impact of climate change, that we have seen, all are aware, well aware that IPCC report that extreme the climate change not only gives the mean pattern, suppose mean temperature is increasing. In addition, what is more dangerous is the severe events or extreme events are increasing. This we have also, as well as our IPCC, as well as our Indian IMD also brought out several reports on climate change, which gives that what the different areas we have identified which extreme events is giving have more increasing trend or significant changes are there. We have already identified, so that extreme events are more dangerous, and that gives different health hazards, including health hazards. And there is a rise in climate sensitive livelihood of that, while that occurrence of these extreme events means extreme temperature, rainfall, cold wave, landslide, drought, that is projected. That is same area what some question that we have, same area we have given flood risk as well as drought risk, because in the same year, if you see some area, we have increase of frequency of drought as well as frequency of, so sukha khara both are more chance. So we have to take the necessary action, and as a result of drought or flood, there are so many diseases are there that we have to take the action. So addressing vulnerability can help that reduce the risk to climate change by suitable adaptation strategies and better disaster management and mitigation. It also helps in identifying what makes the state or district vulnerable to climate change. It is useful for all official decision makers, funding agencies, experts to have a common understanding on vulnerability and enable them to plan for adaptation. Now, where we are living, rural means whether we are rural area, small island, or big cities, urban cities, all are basically subject to these threats, that is climate change threats, and not only health, all type of factors. And so awareness and so adaptation and that is action plan, climate action plans are necessary for each state, each authorities, means administrative as well as social level. So it affects your food, air, water, that all results to different type of disease also. And we have the, as a result, there are impact on the health basically in terms of disease, not only disease, mental health, medical, physical health, and community health also. And that, just hello. So now this also is not proper same way. It is different categories are affected different, because women, pregnant or children and aged people are more vulnerable for cold wave or heat wave areas, and poor people also. So we have to categorize all type of that is population data, census data, structural data, as well as health data. So that factors, so demographic factors are there, biological factors are there, health status, socio-political condition, all are the vulnerable, that is vulnerability factors. And that exposure pathways are the extreme weather events, heat, almost all, we have actually 13, I'll discuss that 13 events, mostly all are related to, can lead to different type of health hazard, health diseases. So we'll directly come So presently climate hazards and vulnerability atlas, what we have brought out. Actually, there are long demands from last several years, defined particularly most of the demand came from the National Disaster Management Authority, that they asked our ministry as well as IMD to have a mapping of climate hazards and vulnerability for different climate events. And ultimately in 2020, that is beginning of that, we have started this work at our climate research and services offices, IMD Pune, because this earlier it was different. Now, since last few years, we have fully dedicated this office with climate research and services for all societal sector. We have different climate prediction, climate monitoring, climate application for different sector, agriculture, all are there. And we are continuously doing, bringing out several products and circulating for different ministries in even international agencies also. So we have, as I told, that our Indian data we have already analyzed, and it has been shown that significant changes in the mean climate patterns are there. But in addition, what is the most threat is the significant increase in the frequency of severe and extreme weather events. So as a result of that, finally we come out this web version, web GIS version. It is indigenously all open source GIS we have used, and we brought out finally our minister, Honorable Minister Dr. Jitendra Singh, finally released it on occasion of IMD Foundation Day in this January 2020. So this is the main page, home page of this. So basically 13 events are there, and it is brought out in Hindi as well as English. Yes.
Dr. Pulak,
Yes.
this is the part you should start giving because this is the introduction to your atlas.
Yeah,
so,
so I will directly.
I'd like you to go through that website that you have developed.
Yeah, I am just
able to make use of that thing.
I'll just so I'll come in that. Before that, this summary of that atlas basically. This atlas gives basically we have used different type of data. Main problem is that for bringing out any this climate related or any, we require the data. So analyze, we have used different type of data, climate data as well as census data, population data, housing density data, and different statistical mathematical model, mathematical methods are used for computation of different statistics. And we come out with the map of this vulnerability scale using normalized vulnerability index in different scale. And based on that, at 13, that we summarize that that percentage of districts and populations are affected, that different 13 hazard events or vulnerable events that is available. And this is the highlight. This is also there. And just one point I'll bring that basically this is main important, that we have to identify there is a further scope of that improvement. What we have brought out, we have to go ahead with this. Suppose this is example of one this health outcome. We have to combinely hazard, risks, and vulnerable. We have to combine to have a multi-hazard system. Just for example, we have brought out, suppose this is the heat wave map, and so that. So this gives the which is the vulnerable area, heat areas in the district. And so as you know, this heat wave same vulnerable. If we use the population data, children are more than 60 years are more vulnerable compared to young age. So that type of data, if you prepare this, we are already doing that. Suppose population vulnerable to this. So middle one, the first one, if we combine this population vulnerability and as well as our present atlas, so we have more implication, that is which areas, districts are more vulnerable finally. So this type of works we have already started after doing this. And these are the, in addition to that, just 2 slides I will show that We are also doing some health sector, some regarding malaria. As I told that we are involving in malaria vector program. So from 2017, basically we have started issuing the weekly bulletin, basically climate outlook this is, and based on our transmission window, that is malaria or dengue vector-borne transmission window, we are issuing that forecast district-wise for the coming week, 2 weeks, which are the area which is having the possible favorable transmission window that can help for the malaria outbreak, district-wise, first week and second week. And in addition, we have taken that initiative with Malaria No More and state government of Odisha for malaria elimination program. We are also developing district-specific malaria cases forecast model, weekly, monthly scale, because this transmission window, as it is the universal who's prescribed, and that is also not uniform. We have a variability, defined type of variability, special variability there. We need to refine that state-wise in addition to develop that. So this is one publication. Recently, we have published that prediction of malaria outbreak in the Odisha district. And this also we are using the machine learning that for Bihar weekly malaria outbreak. Okay, thanks. Just now I will stop that. I will go to directly that website. Hello. Yeah. So this is our homepage of this climate web-based climate hazard and vulnerability atlas. And if you see right side, basically, we have given all information of that is about whatever data we have used. I'll slowly discuss that from the beginning of the type of data we have used, all type of data, and as well as the methodology we have used, and also the references. Recent references are there. You can kindly go through that. And if any difficulty, you can contact. We have given our contact email ID also. Okay. Now, as I told, in the climate vulnerability hazard, we have separated because hazard and vulnerability are different. Basically, all are based on climate hazards. But when the hazards become vulnerable, that is causes the death or losses, damages, then it is vulnerable. In the hazard preparation, we have 9 events are there, where we have used basically all our climate data, 100 years more than 100 years data. And in addition, for cyclone vulnerability, we have used our population density, housing densities, that is from the census data to identify or mapping the vulnerable coastal districts. And whereas in climate vulnerability, we have 5 events where we have used the casualties. Because IMD Pune, basically, that is CR Climate Research, we are bringing every year one publication, that is annual disastrous weather report, where only that extreme events or weather hazards which causes the death, at least one death that is become vulnerable. That data we have compiled, that is from 69 or 1969 to 2020, we have used that data. Also information are there. Now, if in the home page, once if you click the climate hazard, here each of the hazard, in addition to that about page right side, for each event we have given about, that is about the wind hazard, whatever methodology we have used, that is given. In addition, we have given, this is the web-based GIS map, and mostly whenever all the event, we have prepared the annual scale as well as monthly scale. Now, just take the annual scale. This is the wind speed. Basically, wind speed are important for any building structure, any type of structural there. And we have calculated, basically, we have used our IMD data, this hourly data, synoptic data, and based on data past 100 years data, we calculated the return period, that is probability of extreme events, extreme wind speed, what is their probable, and that if you pop up that every district, it will show the wind speed of that district in meter per second annual scale. And in addition, we have made that search option also, where you can search left side, you can put the district name, you can search your district, you can zoom facility, that is just like GIS here, everything will be there. And this right side is the wind speed meter per second. So you can go through later that for each of the month, which are the extreme. Now for extreme rainfall, this is basically important climate parameter, rainfall, because rainfall is leading to several climate means impact-based agriculture, water, health. Here we have considered the data from 2019. In addition to complete scale, we have decadal variability also there. Just let us click the recent or 59 to this period. So we can go directly. So that gives your heavy rainfall event. This is our category defined by IMD in heavy rainfall, very heavy rainfall, extremely. We have considered basically very heavy, extremely heavy together. So this map gives the frequency of these annual events, which are the area where, so you can see that this is the probable frequency of heavy, very heavy, all type of, that is greater than 7 centimeter or more. In an annual scale, out of 100 days, some of the areas where we have 35 days are getting more than 7 centimeter, that is heavy rainfall. If you go to southwest monsoon, you can see that out of 122 days, there are areas where coastal districts 54 days or 70 days are getting rainfall events. Because extreme rainfall is important for flood. Whenever you are getting extreme rainfall, for just like 1 day more rainfall, most goes as a runoff and can you put that silent?
Dr. Pulak, your microphone, kindly unmute, please. Yes.
Yeah. Okay.
Yes, yes.
Okay. Thank you. Now, in lightning, we have prepared two type of, in the hazard, we use climatology based on our satellite data that gives the flashes per day, each district's severity. And I'll go in the vulnerability part, we'll discuss the frequency of, that is which districts are more vulnerable to cyclone, lightning. Then again, dust storm, these are the climate. Dust storm basically it is different, that is extreme wind speed, mostly associated with convective activity, and dry, that is thunderstorm is completely different. In most cases, suppose northern part, dry winds are there due to convective March, April pre-monsoon season. So you can, we have given that this is a frequency of, that is average number of days, annual scale as well as month scale. Then hailstorm is there, which are the areas or occurrence are probable getting much more hailstorm days. Fog, then drought. Here drought we have used basically one index we have used, drought, that standardized precipitation index. This is more widely used as a worldwide. More than 100 or 120 countries are using operationally monitoring and predicting. We are also predicting weekly scale, monthly scale, that drought district wise. So this. So you can have the which are the areas, drought prone areas, that vulnerability scale. This is the normalized vulnerability index that gives the which districts are more vulnerable or highly very high vulnerable. Then in the cyclone we have several parameters are there. Cyclonic storm, severe cyclonic storm. Here severe cyclonic storm you are associated with very severe super cyclone or combined, and this gives the return period. Basically return period means this first time basically in India we have calculated the return period based on NOAA technical. They are using this methodology, this model we have used, and this gives the ones you can see that coastal areas how it is vulnerable. Basically it gives almost every 1.5 years this 24 Pargana. These are the basically more frequency of getting cyclone, all category effects. And the coastal area which are more vulnerable, less vulnerable compared to this east coast, western side are less vulnerable. And in addition to return period, we have rainfall associated to cyclone only. So which gives your probable maximum rainfall which districts are giving. So in spite of your return period, some areas are getting more rainfall, maximum rainfall per day. Okay. Then landfall count we have given, that is simply count of landfall based on past data 61 to 2020 data. How many cyclone each of the district has come across. And finally, combining, as I told, in addition, sustained wind, how much this wind is the only cyclone related, that is maximum sustained wind due to cyclone. The coastal area, how much wind can experience due to cyclone. And finally, we combine all this to have a normalized index, that is vulnerability scale. You can, which are vulnerable. Here we have combined this all cyclone data parameter as well as our population densities, housing density, and finally come out that similar way we will do for cold wave or heat wave for including the population data, that is old age, or as I told that one slide I have shown that composite vulnerability. Now I will come to climate vulnerability, where we have 5 parameters. Suppose cold wave. Now this is not based on climate, this is based on the casualties. So cold wave not as per defined by, we have IMD is having defined cold wave definition is there, that is based on temperature threshold. But this cold wave, what vulnerability, it is the actual cold wave received by different zone districts, and that causes the death. Here only limitation is that we have not considered the death, number of deaths. We considered the event, at least one death occurred, that event we have considered. That is, if we combine the number of deaths, that is casualties, with this, it will be more. That is, there is a scope, as I told, of improvement of this vulnerability atlas. So which are the area more cold wave, that annual scale, or cold wave basically occurs December to March. And so we have 1 month annual and 4 months separately. Then similar to we have heat wave. So all this vulnerability basically, as I told again, it is the event which have the casualty, at least one death occurred during this period. That is 1969 to 2019 data we have considered. Then flood and lightning, as I told that earlier, it was climatology, that is hazard portion you will get lightning, but here you will get the number of lightning days causing the death, as well as your normalized vulnerability index can basically Odisha are more vulnerable to lightning. So this Odisha is getting more, most of the districts are vulnerable, high to very high cases. Then snowfall, we have the snowfall data based on the data we have prepared. So that's all basically. As I told, any queries are there in the homepage. We have given contact number, email ID, and details methodology are there. Now, if any question are there, I'll be happy on to answer.
Okay. Thank you, Dr. Pulak. And I will probably like in 2 minutes to first summarize for my program offices. This website is available imdpune.gov.in, which
Yes,
you
sir.
can see on the screen, imdpune.gov.in, and
It is
there
also
are-
available in Mosam Delhi site, mosam.gov, mosam.imd.gov.in. In the main web page, you can see that anyone can click that. So in our
Yes.
IMD Delhi website as well as IMD Pune website.
Okay, so IMD Delhi website or IMD Pune website, you can access this atlas online. It's free of cost and it's available for all districts to make use of this data. That is an important point that you should know. Another thing is that it has addressed 13 areas of climate hazards that are of importance to us. Some of them in the program we have been constantly been trying to work with. The heat wave, the cold wave, the floods, drought, snowfall in hilly areas, and extreme rainfall. These are some of them which have been of a constant consideration for the program, and so it will be of immense use if you can look into historical information and use that information to understand how is your district placed in risk in your state compared to other places or to other districts in the country. That helps you to prepare and plan accordingly, that okay, my district is flood prone. Historically, the vulnerability, the hazard is clearly indicated. You can see the levels, you can see various parameters which have been provided, and quite important parameters have been provided, especially of extreme level events and other variables of importance that you can make use of. So in that, I would also like to say another word, is that we in this website, as explained by Dr. Pulak, you would see that he has accounted for the exposure variable, that is the climate hazard, that he has accounted for in most of the places. He has also tried to account for population density and house density as some of the sensitivity or vulnerability factors in certain analyses in this work. But of course, as vulnerability assessment will comprise of exposure, sensitivity, and adaptive factors together, so it is well understood that an overall vulnerability would also look into many other additional factors, which over the time, maybe as he has said, they are making efforts to develop it further. But irrespective of that, you already have a good understanding through MAP of at least what is the, and you can factor in the other factors of sensitivity and adaptive capacities to understand how is your district rank in your state in context of overall vulnerability for your climate hazard. Now, there are one or two broad questions that I had in my mind when Dr. Pulak was making this presentation, which I will initially ask Dr. Pulak, and then any questions that may be on the chat box, question answer box, I will try to post that for him. The first question, sir, is you mentioned that out of 13, you have 9 address for hazard and 5 address for vulnerability. You also explained that in hazard, you have primarily accounted for factors, which is the climate events that have happened in historically, and you have also accounted in some places for certain vulnerability factors like population or house density. But in the climate vulnerability section, you have additionally accounted for where did we have at least one death, and suggesting that there is a real time of health hazard because there is a death happening on account of those climatic factors. Because you have 13 overall, 9 on 1, 5 and all, that adds up to more than 13. So my question was, do you have any of that for which you have both an hazard and as well as a vulnerability map in the same?
Yes, sir. Yes, sir. As I told that for lightning, we
Yes.
use that satellite data for climate. It is in the hazard because it is the climatology. You have the first part, that is per square area. That idea gives the climatologically which areas are more occurrence of lightning. But all lightning cannot lead to that is vulnerable. So in our vulnerability map, if you compare that with the, so you have the idea which are area, because there are many areas lightning are there, population
sir.
may not be there.
My humble request is, if you could on your website, for the sake of the audience, show them how the map suddenly changed in your hazard section to vulnerability section in the lightning component, so that they can understand the fine differences between the two.
Okay, just I share the screen again. So this is the under hazard. Suppose under hazard, if we click, this is the annual pattern. We have lightning, that is lightning pattern, that is flashes per day, per square. We have given already flashes per square kilometer per day. That is per square kilometer. These districts are getting more flashes. Okay. Now, just if we go from this, so we have the areas, these areas which is northern, extreme northern part of the country, as well as our Assam, Meghalaya, this area, northeastern part, and Odisha also there. Now, as I told, if we go to now vulnerable area, it is the Odisha which is showing more vulnerable. So we'll see both number of days that gives. So where it was the so because population is less, there are other factors are there, so death was very less. Whereas Odisha,
Okay.
it is
So
showing. As well as Maharashtra part, if you see that Maharashtra, that though climatology, it was not that much vulnerable, but since population are there and they are more affected due to lightning. So Maharashtra, Odisha, even northern part of this AP, Andhra Pradesh. So that comparison can easily find out which is more vulnerable. Okay.
Right. So I think this is for the clarity of my program officers. You understood that it is not always necessary that a climate hazard existence at a very severe level is the only factor that is going to make you overall vulnerable. And he has demonstrated in these two differences of the map that while you could see that there were more frequent lightnings at severities in probably the northern and the northeastern part of India in lightning context, but when he shifted it to additional factors to see how much climate vulnerability is there, then it was more towards Odisha, and it went even to Maharashtra, where there was even not that much level of severity of the striking of lightning. So that's how multiple factors lead to an overall vulnerability, and therefore in his presentation he kept on talking about how so many more factors are important. But the good thing here is that we already now have a district level map of at least the exposure variable for your ready reference. The remaining variables you are better equipped for your own district, account for them and do vulnerability assessment. Dr. Pulak and his team are definitely trying to work better by additional new databases and making better vulnerabilities, as he said, but that might take time, but at whatever tool is available is a wonderful thing that you already have. One more question, Dr. Pulak, that I have in my mind is, you mentioned about what is so-called normalized vulnerability index. So I would like to explain this concept in simpler terms for my program officers. What do you mean by the word normalized vulnerability index?
Just with the example, if see, so in many cases, suppose we have the number of days in different number of days is different for different areas. Now, if the data is normalized, that is all data is, it is as referred in different literature. We have given the literature also. They have used this index. That all the data we have normalized into 0 to 1. Okay. So after normalization, you have the all data in the 0 to 1 category, and based on quarter, the first, that is first 25%, it is low category, and top, that is 75 to 100%, that gives the very high. So it is basically to idea is to identify the zone based on, because data is different for different events. Suppose map, heat wave map, you have the data number of days is different here, and for hazard also similarly different number of days. Simply seeing the number of suppose, so seeing the number of days, it is difficult to identify, but once if you normalize the data and identify the zone, that gives the better picture. So that is risk areas or zone identification. We use this is well used, that this formula, nothing but a normalization. Basically we took the month wise, which month is the maximum value and minimum value, use the simple mathematics, that is maximum minus actual for that district, then minus minimum divided by maximum minus minimum, that leads to all 0 to 1.
Right. So I think in simpler terms, we can tell for my program officer, it is a way in which you have tried to standardize the values so that they can be comparable and be categorized at different levels in comparison to each other, and therefore you can easily classify them from nil to very high values. Am I right in saying that?
Yes, yes, sir.
Okay. So that's a few of the questions. Considering that it's already time that we should end, I'll just seek out from my program officers if there is any question in the question box. I will wait for a question and then probably ask if anyone has asked any question. Meanwhile, while we wait for any question, Dr. Pulak, yes, I would like to request you, you mentioned about the weekly bulletin that you have been working on, in which you have been sharing about transmission windows on vector-borne diseases. I remember some time back you had initiated an exercise by asking on a Google form about what meteorological information people would like to have. I had requested many of my state program officers to provide their inputs. So I would like to know, would it be possible to circulate this weekly bulletin on an email list of my program officers so that they can make use of that that weekly bulletin in their own state and district?
Yes, sir. Yes, sir. Definitely. you kindly share the email IDs, all this, and
Okay.
it will be actually further improved once if we use that, if each state of your officer, they use this bulletin for the district and validation. Basically, now we are validating with our, suppose for week 1, week 2, we are giving the transmission window temperature, and we are validating only the based on temperature, whether, because forecast model, our different forecast model, it is not exactly correct. How far our forecast was correct, that we are validating. In addition, if each your officer can validate not in real time, suppose after later 1 month your lag period, so it will be further improve that our. So I will definitely will, if you send that email IDs, or I will
Sure.
mail.
So we will take an exercise of compiling an email list, mailing list, and would be sharing that with you. And I will request my state and district officers, as what he has suggested, when you receive them, try to validate that, because that projections give you an understanding of what about to come in your district and in your state in context of surge of a vector-borne disease. And if it happens in reality, you can share that real information back to him, maybe whenever you are completed with it or done with your exercise of dealing with it, so that he can find how he can improve his prediction tool. Okay, so that we will try
Sir,
to.
what you're mentioning, actually just 2 days yesterday, day before yesterday, or we have a similar meeting for the health related or DGM. So he mentioned that actually that initiated, I think, from, because DG was noting, he asked me what is the status that Google Form defined. I think headquarters, they have initiated. It will be, I'll be happy if you just that communication share to us, to me.
Okay, okay, that's another area.
That Google Form or all areas.
Yeah, there was a Google form in which we invited comment from our state program officers for what meteorological services would you be interested in, and they did provide that. And so I will definitely get back to you with that. Now we have a few questions that have come, and I would like to pose those questions to you. One question is that can we predict any hazard in the site using this this web tool that you have provided us? Would it be useful for predicting hazard using this tool?
Actually, as I told, that IMD is issuing that warning on impact-based warning system, different that is from nowcast, that is few hours to different temporal scale, spatial scale. That gives the extreme hazard is nothing but extreme event, just like heat wave. We are giving prediction, as well as we are also seasonally. The Dr. Sijit is there. We are cold, that is winters, before winter season and before that is warm season. We are giving the heat wave. Now, in addition to all our early warning system, these hazard based on the past data, that is climatological, and that identify the zone areas, that is risk zone or vulnerable zone. That, as I told, that if we have the forecast of that warning system, same area of district, suppose forecast is giving, suppose southern part of Bihar. Now, some districts are maybe more vulnerable based on past data. That vulnerable means that caused deaths more. So we have to, our state, they have to take action for that district more compared to other districts, though IMD is giving a warning. So that helps combinedly join. Directly hazard prediction, it cannot give from this atlas.
Okay.
Okay.
Another question that we have from one is that where can we read about all the indicators that have been used in vulnerability calculation in this web tool?
So as I told, in a home page, we have the right side, that is about side. One is atlas summary of the all result, what I have shown. And so here we have shown that summary wise, that is final summary state wise. And the about, we have given all information about the category wise. Suppose what I told, that normalized vulnerability index, and the references also from where we have taken. as well as each of the, suppose climate hazard, all 9 events we have shown, that is definition as well as IMD definition, how it can impact a different sector, what type of data, methodology, all are given. In addition, our category, suppose cyclone we have used, this is the IMD category, and we have combined that cyclone and 6 to 7, that is severe, very severe, super cyclone into one category. That all classification category, all information are given. In addition, if you are interested, all the literature we have given, that is available along with the different recent, that is hazard information. One can have recent publication October 4, 2021, that is idea of vulnerability or hazard, what is the definition, what is how you can use for vulnerability assessment. That is that all reference are also there.
Thank you, thank you. Now, one last question that we have here is, someone has once again requested for an elaboration, if you may please. His question is, can you again elaborate on climate hazard versus climate vulnerability, the two groups that you have, what do the two different mean?
Again, that hazard are the, which is that basically it is related to extreme events. That is the hazard based on climatology. But when that any hazard, any gives the hazard, but all the hazards may not be vulnerable when it have an impact. So already that presentation, I will share the presentation also later. So that whenever that hazard gives the have an impact on the society, causing that vulnerable, either human loss, cattle loss, or economic loss. So then it is the vulnerable.
And in this particular exercise, you said that you have taken at least one death as the parameter to suggest vulnerability. Right? You haven't taken all deaths, you have just taken at least one death as a criteria. That's right. Okay. With that, I think most of the questions have been answered. And once again, on behalf of all my program officers and the team that we work with, I would like to thank Dr. Pulak and his team at IMD for the wonderful work they have done and for sparing your time, valuable time in making us understand. We will continue to be in touch and try to make use of this wonderful work that you have done and try to see that we can use it in our program. Thank you very much, Dr. Pulak.
Thank you, sir.
Thank you for your team.
Thank you for the invitation once again, and we'll be happy to go ahead with this initiative.
Good evening. Bye.